All right, so today we're going to learn Unit 1, Objective 1, Parent Graphs. So, there are 4 important graphs that we need to learn for this unit. These will be the bulk of our unit, is understanding everything we can about these 4 functions, okay? So the first function is a linear function. We're referring to lines. Hence, there's the word linear, okay? These lines can be in any direction, so we're dealing with lines. And then we have quadratic functions. Quadratic functions forms that U shape, okay? We can have an open up quadratic or an open down quadratic, but usually forms this U shape. We can have going down U shape, but it's always this U shape, okay? That's the quadratics. And then we have linear absolute value functions. It forms a V shape. So it's nice and sharp. It's different than the U shape. The V can open up, or the V, the absolute value function, can open down, but these are the usual shape, okay, the general shape. And then we have an exponential function, and it forms the J shape, okay, the J shape. So those are the 4 functions we are going to be working with in this unit. It's good to know the general shape of the functions before we even get more in depth with each of them, okay? So please have those 4 shapes in your mind. Let's go ahead and start with the linear. The simplest function of any of the functions is the parent function, okay, the parent graph. So let's go ahead and start with the parent graph for the linear. The parent graph is y equals x. Whenever we want to graph a function, we always want to start with a point. We always want to pick a starting point. So when I look at this, the easiest point for me to plug in here for x would be a 0. If I pick 0 for x and I plug in here, since y equals x, then 0 for x would also equal 0 for y. Therefore, we have the starting point of 0, 0 for our linear function. This m in front of the function represents the slope, so that's super important, okay? We can go ahead and highlight that because we are going to count the slope from one point to another. If you look over here in front of the x, that's where the slope is written, I don't see any number. It's because it's an invisible number 1. Okay? So if it was a 2, it would be written. If it was a negative 1, it would be written. If it was a 3, a 4, a negative, any other number, it would show. But because it's invisible, it is a implied number 1. So our slope is 1. From here, I can go up in the y-axis 1 and move over on the right direction of 1. So up 1, run 1. So there's my second point. I can keep on going, up 1, run 1 for a third point. I can do the same thing on the left if I keep the pattern. So I know my next point is going to be over here, and my next point is going to be over here, okay? Now let's double check that this is correct. If I plug in a 1 for x, right here in my parent function, if I plug in a 1 for x, since x equals 1, and it also equals the y, then that means that when I plug in a 1 for x, I get a 1 for y. There we go, 1 for y. If I plug in a 2 for x, right in here, 2 for x, tells me that it will also equal the same value for y. So 2 for x equals 2 for y. So therefore, I know that my points are correct. I use the correct slope. If I plug in a negative 1 for x, I get a negative 1 for y. Because that is correct, we checked our slope and we checked some additional points, I can go ahead and draw a connection between all my points. So there is my line. Let's go ahead and put arrows at the end of this because it goes on forever, okay? So that is my line. We counted the slope, up 1, run 1 to the right, up 1, run 1 to the right. Or down 1, left 1 if we're going to the left. Okay, the opposite of up 1 to the right 1, it's down 1 to the left 1. Okay? And that's how a linear behaves. Let's do one more linear right here with a different slope than 1, okay? Because 1 was kind of simple. We always start picking a starting point. Start point. Well, what would be the easiest point to plug in here for x? I believe if we pick 0 for x and we plug it in here, it would be 2/3 times 0. Well, anything times 0 is 0. So we would get a 0, 0, right? 0, 0. So that's my starting point. We can count the slope. Let's write down the slope. The slope is m. It's up to run 3. Because it's positive, I'm going to run to the right, okay? So I'm going to go up to run 1, 2, 3. So that's my second point. If I go up to and run 3 more, I'm kind of outside of the graph, so I'm not going to go ahead and do that, okay? I'm going to just 2 points right here. It's good. But that doesn't form an entire line. It would be very, very good for us to have a point on the left as well. So remember, the opposite of going up 2 and to the right 3 is going down 2 and to the left 3. So therefore, I continue the pattern, okay? So I can go ahead and draw that together. And let's go ahead and put arrows, tiny little arrows at the end of this to emphasize that our line goes on forever to the right and forever to the left, okay? So we use the slope of up 2, run 3 to the right, down 2, run 3 to the left. The slope is positive, so my function is increasing. It's going forever to the right, and the pattern continues to the left, okay? All right, let's go ahead and switch to quadratics, and then we'll come back to more linear practice and other practices down here, okay? All right, so quadratics. Remember, we're dealing with the U shape. The simplest parent function for a quadratic is y equals x squared. The key feature of a quadratic is having that little tiny exponent 2. So that's a key feature of a parabola. It's a quadratic, okay? The shape, we call it parabola. So that little number 2, it's a square. It's a key feature of quadratics. So what would be the best value to plug it in here for the parent function? We believe 0 would be the easiest to plug it in, okay? So when I plug in a 0, 0 squared is 0. So y would equal 0. So that's where my function starts, right here at 0, 0, okay? Now, notice that in quadratics, we don't have a slope. We have a stretch. It's very, very different than a linear. So let me make a big deal out of this right here. It is not a slope. Not a slope. Okay, make a note to yourself. The reason why I'm making a big deal of this is because a lot of the students get tempted to continue counting the stretch, and we cannot do that with quadratics. And I'll explain to you a little bit more why in a second. Okay, so it's not a slope. We're only going to count it once. So if I picked a 0 and plugged in here, 0 squared gave me 0, gave me my first point, which is a starting point. My stretch is 1. Is that invisible number 1 that is in here, representing my a value. So I'm going to go up 1, and 1 to the right, okay? But this is not a line. I know you're tempted to think it's a line. I want to make a U shape. So I'm going to reflect that point directly across the y-axis right here. And that forms my U shape, okay? I'm not going to draw yet because I want to pick an additional point for you to see. For example, if I pick 2 for x, 2 for the x value. If I pick a 2 and plug it in here in my function, 2 squared equals a 4. So my y value would be 4. Up 1, 2, 3, 4. That's where my extra point would be. Let's do one more so we can understand why it is not a slope. If I plug in -2 for the x value, -2. -2 squared is -2 times -2. So -2 squared is also a 4. So I would reflect the same exact value right here as a 4, okay? 4 for y. So notice that the +2 and the -2, both, when I plug it in, gave me the y value of 4. When I plugged in 1s, I got the y values of 1s. And there's my U shape, okay? So notice that if you were under the wrong impression of thinking up 1, run 1, up 1, run 1, like we do with linears, you would be incorrect, okay? So this one value is not a slope. We cannot keep on counting it as we do with linears, all right? So once you understand this, you will remember, hopefully, that you cannot count a stretch more than once because it only works one time, okay? Let's do it one more quadratic right here. Y equals 2x squared, okay? I'm still going to pick my starting point so I know my function, where does it start? Well, I'm always going to pick 0 if I can. If I cannot, I'll pick something else that helps me get to a 0, but as of right now, why don't we pick a 0? If I put in a 0 in here, 0 squared is 0, and then 2 times 0 is still equals a 0, so the y value would result in a 0. So if I plug in 0 for x, I end up with 0 for y, okay? And if you need to see that, you can do it separately on a piece of paper. I will do it for you one time so you can see, okay? So if I have y equals 2 times x squared, y equals 2, 0 squared, because we plug in 0 for x. 0 squared is just 0 times 0, which equals 0, right? So you get 2 times 0, and then 2 times 0 is just a 0. So see, we plugged in 0 for x, and we got in 0 for y, okay? So it's just a quick little way for you to see that what is the value that I should plug in to find a starting point. So I plug in 0, and I got a 0 out. Okay, now my stretch, my a value stretch, it's a 2. Remember, I'm going to write to myself a note. It is not a slope. So please don't count it more than one time because the pattern does not continue like a slope, okay? So from here, I'm going to go up 2, and I'm going to go 1 to the right, okay? I'm going to reflect it over across the y-axis so I can form my U shape. And there's the U shape. We have enough points to form our U shape. So in order to form our U shape, we need 3 points, okay? And there we go. So that is a parabola. It's a quadratic function, okay? Now let's move on to, I would like for you to try the bottom ones by yourself, okay? So you can pause the video, and I'm going to give you a hint here, and then I want you to try the bottom ones. So let's come back to a linear. Let's learn about linear. So a linear function has a linear absolute value, has a V shape. I remember because it says value, V, it has a V shape, okay? So look at the general parent function is y equals the absolute value of x. We learned way earlier, maybe in 7th or 8th grade, that absolute value is the distance is a distance from 0. Let me say this better. Is the distance a number is from 0, okay? How far a number is from 0. So the best number to plug it in first, again, would be 0, right? So let's plug in 0 for x. So how far is 0 from 0? Well, 0 is, it's exactly 0, so there's no distance from 0 to 0. So that's our starting point. If I plug in a 0, the absolute value of 0 is 0, which results in a y equaling a 0. Okay? So So there we go, our first point is 0, 0. In a linear absolute value, we can count that value in front of it as a slope. Okay, linear absolute value and linear functions are kind of cousins. Okay, it's not mathematically correct to say that, but they are related. Okay, so they have the same slope. The average rate of change as the function is changing and moving, it's consistent. So we can count that as a slope. So that number in front of the absolute value right here, it's a 1. So I'm going to go ahead and count up 1, run 1. Up 1 from here, from the second point, up 1, run 1. And I can keep going forever. However, this is not a line, it's a V shape. So I'm going to reflect it over the same thing to the other side. Over here, up 1, 1 to the left, up 1, another 1 to the left, and up 1, another 1 to the left. That's how it forms my sharp V shape. Now let's understand what I was saying. The absolute value is how far a number is from 0, okay? So the number 1 is 1 unit away from 0, but so is the number -1. -1 is also 1 unit away from 0. The number 2 is 2 units away from 0, but so is the number -2, is also 2 units away from 0. So that's why they are consistent, okay? It's a constant average rate of change here. So the slope stays the same on the left and on the right here, okay? There we go, we connected the dots. We put arrows at the end of it so we can show that it goes on forever. And that's our absolute value function, okay? All right, so additional points. I should go back over here, on quadratics. It asks for additional points. We plugged in a 2, we got a 4. We plugged in a -2, we also got a 4, okay? Now over here, when we plugged in a 1, the absolute value of 1 is 1. So 1, 1 could be an additional point. We could also say -1. How far is -1 from 0? The answer is 1. So those are some additional points, okay? All right, so now let's go ahead and do another absolute value. Notice that in order for us to graph, we always want the y value to be isolated. Notice before, if you need to glance back, the y value, the y was all by itself, the y over here was all by itself, and on the other ones as well. So I want to get this y by itself before I can make any decision. So I'm going to divide by a 3. If I divide it on the left by a 3, I must divide on the right by a 3 as well, okay? 3 divided by 3 is a 1y, and then we get a 2/3 absolute value of x. So I divided by 3 on both sides, so the y value can be isolated. Y equals 2/3 absolute value of x. What number should I plug in? Well, let's start with a 0. If I plug in a 0 for x, the absolute value of 0 is 0, and then 2/3 times 0 is 0. So we start with 0, 0. Okay? Notice that 2/3 is positive, and that is a slope. I can count up to run 3. So up to run 1, 2, 3. And if I do the same thing to the left, up to run 1, 2, 3 to the left, I will have the V shape that we need for an absolute value. Now, could I continue counting up to run 3? Yes, but we would be outside of the grid, and that doesn't look pretty, okay? So some students may ask me, when do you ever go down? If this number, if the slope was a negative, I would go down, which is the next case, okay? All right, so let's go ahead and do an exponential and the J-shaped function right here. All right, so let me go ahead and zoom in a little bit, make it better. Give me a second. There we go. Okay, so an exponential has a base number that is given to us. Okay, there we go. y equals, the base number is always given to us, and the x value now is moved up to the exponent position. So the key feature of an exponential is that the x is up in the exponent, okay? It's very different than the other ones. The x were not up in the exponent, so the exponential, the x is on the exponent. Let's go ahead and plug in a number here. Well, the best number to start with is plugging in a 0. Plug in a 0 for x, we get 2 to the 0 power. 2 to the 0 power equals 1. So when I plugged in a 0, I got a 1 for x. So that's where my graph actually starts. 0, comma 1. Let's do one more. 2 is the base, and we get to pick the variable x. We get to pick what we want to plug in. Why don't we plug in a 1? So 2 to the first power is just 2. So when I plugged in a 1 for x, I got a 2 for y. So 1, comma 1, 2. Now, why did we not get a 0, 0? Let's look at over here. The starting point, it's 0, comma 0. Why? Well, if I plug in a 0 for x, notice that I did not get a 0 at all. I did not get a 0, I got a 1. So why is 0, 0 our starting point? It's not. Notice what it says right underneath it. It's for an asymptote. Okay, an asymptote is a line that is an invisible. It's an invisible barrier that we don't touch. So I'm going to put 0. I'm going to put a bubble, an open bubble for my starting point, and I'm going to draw this invisible barrier. We call it like an invisible line. Okay, this invisible barrier we don't touch. Our graph will not touch that invisible barrier, okay? It's called an asymptote. But I know that my graph is supposed to be a J shape right here, like this, okay? And it's gonna go down forever, but it's never gonna touch, it's never gonna cross or touch that asymptote at all. If you wanna plug in one more number, just to make sure you have your J shape nice and pretty, the base doesn't change, is always 2. Why don't we plug in a 2? Because it's easy. 2 squared is a 4. So 2 for x gives me 1, 2, 3, 4. My graph should have touched right here. See? So that is an exponential, right? And it goes down forever, but it does not crosses the x-axis. I'm sorry, yeah, x-axis now, but it does not cross this asymptote at all, okay? Let's practice another exponential, okay? If I plug in a 0 for x, okay, 3, comma 0, anything to the 0, oh, let me move up. Anything to the 0 power is 1. So my very first point, I plug in a 0, I got a 1, 0, comma 1. Then if I plug in a 1 for the x value, 3 to the first power is 3. So 1, comma, 1, 2, 3, right here. If I plug in a 2, 3 squared is 9, is too big. It's going to be outside of the grid. I don't want to do that, okay? This might be a little bit too advanced for some of you, but I'm going to do it anyway. 3 to the negative 1. What happens if I plug in a negative exponent right here? It does not become negative 3. It becomes 1 over 3 to the first power, okay, which is just 1/3. So my next point on the left would be a 1/3, and then it would become an even smaller fraction, but it will never, ever touch this invisible barrier right here, which is called our asymptote. Notice that if I plug in a 0, I will never get a 0 value out. So I'm gonna mark this 0, 0, 0, comma 0. I'm going to mark it as my asymptote, which is this invisible line that my graph never touches. So now I can go ahead and draw my graph nice and pretty. I have plenty of points. I have 1, 2, 3 points right here, okay? Some students may ask me, Mrs. Myers, how many points should I have on a exponential? As long as you have at least 2 and you have the correct shape and you have the correct asymptote, you have a pretty good graph, okay? So I would like for you to try to do the next 4 functions down here, okay? Make sure you isolate this. You cannot graph it until y is all by itself. So I strongly suggest you subtract the 3x from the left, but you also need to subtract it from the right, okay? From the right of the equation. So over here, a positive 3x and the negative 3x is 0, and we get the y by itself. And a 0 minus a 3x is just a negative 3x. So see if you can graph that, and then I will share my answers with you, okay? I will share all my answers with you. So you're going to graph that. This parabola already is isolated. The absolute value is already isolated, and our exponential is already isolated. So I would like for you to try graphing by yourself these 4 functions to practice what you have learned here from the top, okay? There's a little hint here on this one. Notice that is negative 3, so our U shape is gonna go down, okay? So I want you to try that one. The same thing with our negative 3. Our V shape is gonna go open down, okay? And our exponential is just the same thing I was doing over here with the 2, and then I did with the 3. I would like for you to try with the 4. Remember the asymptote, okay? So I would like for you to try this bottom 4, and then when we see each other, we can check our answers to see if it's correctly, okay? Done correctly. All right, let's move on to domain and range of a function. Let me zoom out a little bit. Okay, so before I move on to the domain and range, let's talk about 2 special cases of linears, okay? So these are 2 special cases that usually throw people off. We have the horizontal lines are always in the form of a y equals k. K represents a constant. So whenever I see a y equals a number, y equals 2, y equals negative 2, y equals 3, y equals negative 3, it doesn't matter. It is a horizontal line. Now the students have a hard time with it. They have such a hard time with it because they think of the y-axis, which is right here, they think of the y-axis is vertical, which is true, and the x-axis is horizontal, which is also true. However, the x-axis is also the line y equals 0, okay? Because right here, the y, in all of these x values, the y value is 0. So it is a horizontal line whenever you have a y equals a constant. So this y equals 2 is just right here on the 2 value of the y, and we're going to just draw a horizontal line, okay? There we go. There's a horizontal line, the best I could, y equals 2, okay? I know it's counterintuitive and you get confused because you always think that y-axis is a vertical line, but it's actually y equals a constant is a horizontal. Okay, which is a little opposite, right? It's the opposite of a vertical line. It's in the form of a x equals h, and h represents a constant. So whenever I have a x equals a constant, it is going to be a vertical line, okay? X equals any number, it will be vertical. So I know that this is the y-axis. I know that, and you'll have been always, memorize that, and this is the x-axis. However, the y-axis is where the x equals 0, okay? So this is what? Right here is 2, 0. Over here is what? 4, 0. So this is where the x always equals 0. So if you ask me to graph x equals negative 3, I would go to the x-axis. Where does it equal negative 3? Right here. And I would draw a vertical line because right here, all the x values will be negative 3. Okay? Any point you pick on this line, any point you pick, like if you pick this point right here, what is the x value? It's negative 3, 1, 2, 3. How about if I pick this one over here? It's -3, comma, 1, 2, -3. So any value on this vertical line over here for x will always be -3. So an x equals constant is a vertical line. A y equals a constant is a horizontal line. Those are the two special cases, okay? Now let's talk about domain and range. So the domain of a function is the set of all the x values. Why don't we highlight that? Because it's super important, okay? So domain, we're talking about x values, okay? So the domain of a function is the set of all the x values for which the function is defined, for where the function exists. Now the range, let's use red, the range is the y values. So just remember that, okay? The range is the y values for the function, okay? We want to use interval notation, okay? If you're not familiar with interval notation, it's something that we're going to have to add to our vocabulary. We're going to use brackets. Brackets look like this, okay? These are brackets. We're going to use brackets when we want to include something. So we want to include. We're going to use parentheses when we don't want to include. So parentheses means not include. All right? However, whenever we're dealing with plus or minus infinity, we always use parentheses because negative infinity and positive infinity are not numbers, they are ideas. So saying, oh, you know, I'm going to go all the way to negative infinity, that's an idea, and we don't include the values, negative infinity and positive infinity. We always do domain and range from smallest to larger numbers. We never put bigger numbers first, so always the smaller number first, then the larger numbers. And we use this little u to connect intervals if there was a break in the function, okay? So if I had an interval and then the function take a break and then continue somewhere else, I would have two pieces of a function. We'll learn more about that later. I would use a union, okay? I don't think we're going to use this at this point, so just focus on brackets includes, parentheses not include, and whenever we're dealing with positive or negative infinity, we just want to use parentheses, okay? All right, so let's go ahead and dive into domain and range. So we are not doing inequality notation. We are only doing interval notation, okay? So I'm going to do interval notation for all of these graphs, domain and range. All right, so first let's do the domain. Domain is the x values. I'm looking at the function from left to right. That's my x values right here, x values, and this is my y values. What I like to do is I like to frame the function. I like to look at the function and talk about it. What is all the directions that it's going? Where is all the direction it's going, okay? This function is going down here, negative infinity, on the left, right? So on the left of the graph here, left, I'm going left and down. So I'm going down to negative infinity, but I'm also going on the left. So left, down. On the right, I'm also going down, okay? So I'm going down, but I'm also going to the positive infinity on the right. Okay, so as the numbers are getting bigger, I'm still going down. Doesn't matter how big the number is, I'm still going down. However, it stops right here at 1, 2, 3. Stops right here at 3. It doesn't pass that. As a matter of fact, it started here and then it's going down on the left and on the right. So I framed my function. I framed on the left, I framed it on the right, because the function is going to the left and to the right. It's going down, and it started right there. So that's pretty easy. Now that I have everything framed, I'm going to talk about the domain, and I always go from the left first. So negative infinity, that's where my function is going on the left, and is also comma going to the positive infinity on the right. Okay? Now let's talk about the range. The range, we're talking about the y values, and we always start from the lowest value to the highest value. Well, the lowest value here is negative infinity because my function is going down. So the lowest value is negative infinity. And if I keep coming back up, the highest value of y is going to be a 3. Do we want to include that 3? Yes, we do. If I want to include something, I use bracket. Okay? I use parentheses because I was dealing with infinities, okay, positives and negative infinities, so I kept on using parentheses. The moment I saw a number, a 3, and I want to include it, I used a bracket, okay? All right, let's frame the next function. Is the absolute value going to the left? Yes, so let's go ahead and label negative infinity on the left. Is the absolute value going to the right? Yes, on the right is going to positive infinity. So it's opening to the right and to the left. Is it going up? Yes, up to where? Up to positive infinity. Cool. Is there a bottom to it? Is there a lower value? It sure does. Right here, -1, -2, -3, -4. That's the lowest value of my function is a -4. -4. So I framed on the left, I framed it on the right, I framed it, I know where it's going, it's up, and I framed it on the bottom, the lowest value is -4. With that, we can go ahead and talk about our domain, and we can talk about our range. Domain is the x values, left and right. So we're going to go negative infinity to positive infinity with parentheses, because we never use brackets in infinities. The range. The lowest value is a -4, and I want to include the -4. My graph touches, not touches, but my graph includes the value of -4. So I'm going to use a bracket for my -4. And it's going up to infinity, and a positive infinity gets a parenthesis. Okay? There we go. All right. Let's go ahead and frame our linear. So this line is going to the right, correct? There we go, to the right, positive infinity on the right. This graph is going to the left, it sure is, so on the left is negative infinity. But on the left is going down, okay, to negative infinity. And on the right is going up to positive infinity. So I have the left, I have the right, I have the lowest value here, the bottom, and I have the highest value, which is on the top. So my domain is negative infinity to positive infinity, and my range is also the bottom, negative infinity to positive infinity. Okay? So from left to right is our domain, from bottom up is our range. Let's go ahead and do an exponential. Okay? So let's go ahead and frame our function. Am I going to the left? Yes, the arrow is saying we are going to the left. So left means negative infinity, left, negative infinity. Am I going to the right? Yes. Okay, if I plug in a 1, I get a number here. If I plug in a 3, I'm going to get a number on the graph. So I am going on the right, I am going to positive infinity. Am I going up? Yes, I'm going to positive infinity here on the right. I'm going down here on the left. However, there's a barrier right there. This dot, 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 dot is our asymptote. Asymptote. We don't touch it. We don't cross it. But we get pretty close to it, so let's label it. 1, -1, -2, -3, -4, -5. So the location of our asymptote is -5. We don't touch it, we don't want to include it, but we want to mention it, okay? So I have it all framed, left and right, top and bottom, or bottom to top. So let's go ahead and do domain and range. Okay, so domain is the x values. We're looking from left to right. Parenthesis for negative infinity, positive infinity, parenthesis. Now, range from bottom up. We don't want to include the -5 because we're not touching the asymptote, the barrier, but I want to mention it. So I'm going to say -5, not including, okay, that's why we're going to use parentheses. I'm not including the -5, but we get pretty close to the -5. And up, our function goes to positive infinity. So we put parentheses as well. So the reason why we used a parenthesis for -5 is because we're not touching it. We're not including the -5. Okay? So, I'm going to frame it, and I'm going to let you write down the domain and range. You can compare with me in class. So, on the left, negative infinity. On the left, we are going down here to negative infinity as well. On the right, we are going on the right. The graph goes to the right. On the right, positive infinity. It's going down to negative infinity down here. We already determined that. And it stops right here. That's the highest value we're going to go. It's a 1, 2, 3, 4. Positive 4. So there we go. There's your left to right is your domain. And here's your range from bottom up. Go ahead and use this to write your range. Okay, we are including the 4. Sorry. We are including the 4. So you should be able to write your domain and range. Okay? And the last one, let's talk about our function. This one is our special case. Are we going on the left? Yes, we're going to the left forever. Okay, so left, negative infinity. How about on the right? On the right, we're going to positive infinity. Okay? How about the range? The range is the y value. Well, the only y value I'm getting here is a 1, 2, 3. That's as a matter of fact, this is a y equals 3 line. Let's write it down. Y equals 3. So how do I show that? Well, the domain is negative infinity to positive infinity. And the range, the only y value that I get is the number 3. So bracket number 3. Okay, so that is a special case. Let's put a star next to it. Okay, a special case for our domain and range. So go ahead and try this one. I would like to see your answers. Okay. All right, last thing, and we're done for this objective, is writing equations. Can we write the equation for the graphs? Okay, I'm going to do the top 4, and I want you to try the bottom functions. Okay, so remember the general parent function is a y equals, I have to find a slope, and then there's an x. The only thing I really need to figure it out is this value right here for m. Okay, what is the m? What is the slope of my graph? Okay, so look at it. We start at 0, 0. Our function is going up. Okay, so let's go ahead and count our slope until we hit another point. Up 1, run 1, 2, 3. Okay, so our slope is up 1, run 3 to the right. So our function is going to be y equals 1/3 x. Let me double check. I drop 1 and I went 1, 2, 3 to the left. So our function, our slope is correct. It's up 1, run 3 to the right, drop 1, run 3 to the left. How do I know to make this a positive 1/3, Ms. Myers? Because our function is going upwards, is increasing. Okay, we always read a graph from left to right. So my function is increasing. Okay, so I know it's a positive 1/3. All right, let's go ahead and do writing linear absolute value function. I know that it's supposed to be a y equals m absolute value of x. I need to figure out this guy right here. That's what I'm trying to figure out, the slope. We're starting at 0, 0. Let's count the slope. Up 1, 2, 3, 4, and then we run 2 to the right. So the slope is up 4, run 2 to the right. 4 divided by 2 equals 2. So that is my slope, is just a 2. So I can write the function y equals 2 absolute value of x. That is the final function I'm looking for. Okay, the same way this was the final function we were looking for. Okay, notice that we're starting at 0, 0. Okay, let's do our parabola. Now that one is a little harder. Okay, it requires this bottom two requires a little bit more work. So we have a y equals a, which is not a slope, x squared. Okay, a is not a slope. Let me write that down. The a value is not a slope. It's not a slope, so I cannot count it. Okay, don't you dare go up to, nope, we're not doing that. However, they gave us an extra point right here. They gave us a little extra point. I'm gonna use this little extra point and plug it in my equation. So extra point, let's find out what it is. 1, 2, 3 on the x-axis, up 2 on the y, so 3, 2. I'm going to plug in a 3 for x, and I'm going to plug in a 2 for y in my function here, and I'm going to solve for a. So let's plug in a 2 for y, 2 equals a, and let's plug in a 3 for x, 3 squared. And let's solve it carefully. The first thing we do in PEMDAS, okay, let me write it down so I don't confuse you guys. PEMDAS. The first thing I do is parentheses and exponent. That's the first thing I'm going to solve. Okay, so 3 in parentheses squared. 3 squared is a 9. So 2 equals a times a 9. In mathematics, we usually don't do A9, we do 9A. So if you want to switcheroo the positions of these two values, it won't still be meaning the same. So 9A. Now I want to get the A by itself, so I want to get the letter A, the variable A by itself, so I'm going to divide by 9. Divide by 9 here, divide by 9 here. 9 divided by 9 equals 1A. So that tells me that A equals 2/9. There we go. Now I know what A is. It was definitely not up to run 3. Okay, it's 2/9. Now I can go ahead and write my equation. Y equals 2/9 x squared. And that is our final equation for the parabola, for the quadratic. Okay? They always give us a little extra point. It's the same thing with the exponential. Okay? I know the general equation, y equals b to the x value. Let's pick this extra point right here on the top so we can plug it in and solve for the base. We want to discover what the base is. So let's see on the x-axis. 1, 2, 3. On the x-axis, I went 3, and then I went up 1, 2, 3, 4, 5, 6, 7, 8. 3, 8. We're going to plug in a 3 for x, a 8 for y. So 8 equals b to the 3rd power. So we're going to have to play a little tiny guessing game here. What number to the 3rd power equals 8? Well, 1 cubed to the 3rd power, it's 1 times 1 times 1, right? It's the 1 times itself 3 times, which is just a 1. Let's try a 2. Maybe it's a 2. 2 cubed. 2 cubed is 2 times itself 3 times. So 2 times 2 is 4 times 2 is 8. There we go. We figured it out that 2 cubed is 8. So that b value must be the number 2, okay? So that number must be the 2. So b equals 2. Now I can write my final equation. Y equals 2 to the x value is our equation for this graph, okay? So that is it for today. This is a 50 minutes lesson, so hopefully you can watch it in 2 parts or 1 part. Take this good notes. I would like to see your notes for the rest of the graphs so we can compare our answers, okay? So there's always a little extra point for you to use in solving for the base. There's always a little extra point on our parabola for you to solve for the stretch. So let me put a hint. Solve for A first, okay? Solve for B, the base. Same thing here. Solve for B, all right? So obviously if we're dealing with linears and linear absolute value, we can count the slopes because they have slopes. But these other 2 special functions have stretches. We have to use the extra little value, okay? So good luck. on your notes. I would like to see your notes when we see each other again. Okay, bye.